Hello, my name is Vítor Ferreira and I'm here to talk about my work that is about protein tyrosine phosphatase deficiency in mice and its ability to protect them against insulin resistance induced by the treatment with olanzapine. Olanzapine is a second-generation antipsychotic used mainly in the treatment of schizophrenia. Importantly, schizophrenia is a chronic and severe mental disorder that affects around 21 million people around the world. It's usually related with psychotic episodes that disrupt the life quality and stability of the patients, denying them of a normal life in society. However, unfortunately, current treatments are able to suppress the symptomatology enough so that patients can be reintegrated in the society. Current guidelines, the first line of treatment to treat schizophrenia is second-generation antipsychotics, which one of them are olanzapine. However, recent clinical observations show a variety of metabolic side effects associated with these treatments, such as abnormal weight gain, dyslipidemia, and hyperglycemia. However, the mechanistic behind these metabolic alterations is still poorly understood. So the main objective of this work is to study the effect of olanzapine administration in wild-type and PTP1B or protein tyrosine phosphatase 1B deficient mice on glucose homeostasis and the mechanisms that are involved. Importantly and of interest, PTP1B is the main tyrosine phosphatase of the insulin receptor, and it's responsible for stopping the insulin signaling inside a cell. And previous works have shown that models deficient on this protein are protected against type 2 diabetes, insulin resistance, and obesity. To achieve this goal, we injected wild-type and PTP1B knockout animals for 8 weeks with olanzapine 10 milligrams a day, 10 milligrams a kilo a day, and at week 6 we start monitoring these animals for their metabolic alterations by analyzing how the administration of the drug is able to alter the animal's tolerance to glucose, insulin, and pyruvate. After 8 weeks, we isolated primary hepatocytes from these treated animals and we test them for their in vitro ability to respond to insulin and glucose uptake. Other group of treated animals were, before killing, injected with 0.75 units a kilo of human regular insulin to analyze afterwards the organ-specific insulin response. Starting by the 5th week of treatment, we saw that these male animals do not mimic the weight gain associated with clinical human patients. However, this just means that the alterations in insulin signaling that we are observing in this work are independent of body weight and adipositive increase. Starting by the metabolic analysis, we can see that actually neither of the interest and experimental groups have glucose intolerance upon treatment for 8 weeks, but these animals present increased fast blood glucose, specifically the groups treated with olanzapine independently of the genotype. Also, these animals, wild-type animals injected with olanzapine, present insulin resistance, insulin intolerance, while the PTP1B deficient mice were protected against these alterations. And finally, also the pyruvate tolerance tests show that wild-type animals injected with olanzapine had pyruvate intolerance, which means a direct impact of the drug in the liver, while PTP1B knockout animals were protected against this. And when we analyzed the liver extracts for the insulin signaling proteins, we saw that these wild-type animals injected with olanzapine had a decrease in their phosphorylation of the insulin receptor and also phosphorylation of AKT, which are all marks of insulin resistance. Moreover, also these animals presented an increase in the content levels of fatty acid synthase or FAS protein. These alterations were not observed in the PTP1B deficient mice. Interestingly, when we isolated primary hepatocytes from these animals, we also test them in vitro for their insulin response, and we saw that the primary hepatocytes isolated from olanzapine-treated wild-type animals presented again insulin resistance by the reduction of the phosphorylation of AKT. Moreover, they also present increase in FAS. Neither of these alterations were observed in the primary hepatocytes isolated from PTP1B deficient animals. Still, in the primary hepatocytes experiments, we observed that also these primary hepatocytes isolated from wild-type animals treated with olanzapine for 8 weeks presented a decrease in their ability to uptake glucose, while the PTP1B knockout hepatocytes maintain their glucose uptake levels. Very interestingly, another important tissue for the whole-body glucose homeostasis is the skeletal muscle. And in here also we see that this tissue presents insulin resistance. The wild-type treated with olanzapine present insulin resistance by reduction of the AKT levels and also GLUT4, alterations that were not observed in the PTP1B deficient mice. Surprisingly, when we analyzed the brown adipose tissue of these animals, we saw that both groups injected with olanzapine had increased UCP1 levels, uncoupled protein 1, a protein that is normally related with thermogenesis and energy expenditure, which means that the treated animals had, independently of the genotype, had increased energy expenditure, which might be related with the fact that these animals have actually a reduced body weight variation. So to conclude, intraperitoneal olanzapine treatment results in an increase of fasting blood glucose, mild insulin resistance, and significant pyruvate intolerance in wild-type mice. And moreover, primary hepatocytes from wild-type mice show a decrease in glucose uptake and a reduction of insulin-induced phosphorylation of AKT levels, suggesting insulin resistance, alterations that were related also with what was seen in the liver and skeletal muscle, and that PTP1B deficiency actually protects the mice against olanzapine-induced insulin resistance in liver, hepatocytes, and skeletal muscle. Finally, and very surprisingly, both groups treated with the antipsychotic agent, namely olanzapine, increased their UCP1 levels in their brown adipose tissue, which might be related with alterations in body weight. However, further research is needed to unravel these metabolic compensations. Thank you very much for your attention. I hope you enjoy it.